Hello, Internet. Welcome to another NL Mathman Math Help stream. Hello, welcome. It just popped up down here in the corner. You got a, oh, I was going to say you got a bonus minute, but you don't. You don't. Now it's actually 1 p.m. It's 1 p.m. right on the dot right now, so you had a bonus like 12 seconds. It's pretty good, right? I mean, how many times do you get a bonus 12 seconds? I guess once a year, kind of. You get a bonus hour, right? But I mean, you lose that. You ever hear of a leap second? You ever hear of a leap second, Chad? That's a good tangent to run off onto, you know, because it's not just a leap year. There's actually a second that gets tacked on occasionally as well. Have a little swig of my Coke Zero that I got here. We're running low, chat. You know, pop is um, pop is in short supply these days, or soda, whatever people call it elsewhere. It's called pop, obviously. Like it pops, right? Like it doesn't soda. Anyway, soda is what you mix like I don't know gin with, right? Or just tonic, I guess. Not really soda. Anyway, so today going to go over just a few topics here, not as many as sometimes today, but as the stream says down there down below, this is going to be the last stream before Easter break. All right, it's going to be it's going to be a bit of an odd Easter break this year. But yeah, if you watched the health advisory yesterday, they did have quite a lot to say about, you know, staying safe over the break and all that kind of stuff, right? But yeah, for my purposes, this will be the last math stream now until 420 Lameo, right? Um, you know, I mean, next week I might. I'm not going to commit to it, so I'm only saying it on here, so it's not in writing, right? Like this is totally not being recorded, so there's no way that you could ever play it back and say that I said this on record, right? Obviously, but I might do a fun stream or two next week. It'll be around the same time of day. I'm considering doing like I don't know, showing off my educational games again, or I don't know, maybe even trying to play a video game or something. Maybe we'll see. But those streams are gonna any um any of those streams are just going to sort of exist and then go away, right? There's going to be ephemeral. Like any video game playing streams that I have are just they're just when it's live and that's it. Educational game stuff I might stick around and put that on the channel, but this is of course a math streaming channel, so that is what I'm going to be doing. That and trying to pull my headphone cord up out of the greedy mouths of my office chair. Okay, so let's go ahead then. Um, oh, well, over here, before I bring this picture down, you got to see the little buddy, little tiny guy. He wanted to play. He didn't know why are all the people sitting there on the steps and looking toward this little like tripod thing. This doesn't make any sense. He didn't want to do that. He just wanted to play. See, he's palming me. He's saying, "Come on, Peter. Come on, do something, do something." He said, "Why are you sitting there?" And Sissy's being a good girl, a little flurry. She was okay. No, she doesn't mind sitting still a little bit. Well, not that from this picture you would think that she's like good as gold and he's the disobedient one. But I don't know. She's part husky. They can get willful sometimes, especially when they're off chasing a squirrel or something. Boy, oh boy, hard hard to get her to come back in those situations. Anyway, let's. Oh, y'all don't need to see that look there. It looks a bit scuffed. I am gonna pop on back over here now. Gonna zoom in a touch on the paper. And then we'll get started. So surface area of regular shapes is what I'm going to start with today. So I believe Ashley was one of the ones that submitted questions for today. I think Ashley might yes, and what you're working on currently should be this activity here. I will show you a little bit just as a reminder of how to do some of these ones actually. So yeah, there will be an extra topic tacked on here. I will also go over converting area again, just really briefly, units of area. It bears repeating, right? Because maybe it's, yeah, I know it can be a little bit confusing at times because if you're going through quickly and you see something that you recognize really well, you're like, hey, wait a minute, I know how to convert inches into feet, obviously, right? It's like, well, no, that little 2 in the corner, that little 2 in the corner was important, unfortunately, right? But this is going to be math. What is this? 1102A unit 3. And just on this worksheet then, I'm going to do, let's see. Yeah, I'll just do question 1. Question 1 is a good one to do. And then I'm going to move on to the uh, surface area of cylinders that I wanted to get to mostly in this course. But I'll do surface area of a rectangular prism first. So it says the base of a rectangular box measures 31 inches by 21 inches. What is the area of the base in square inches? So, okay, there we've got a better example of it. Let me just zoom on in here. Scroll her over. There we go. So now, for question 1, okay, we are focused here. We have got, so the base is all they're asking for, is it? Just the base? Really not the full shape? What is the area of the base in square inches? Okay, easy enough. Right, so the base is just going to be a rectangle, right? The area of a rectangle. And the subscripts, you notice I write a subscript down below the A to just say what the shape is that we're finding the area of. The area of a rectangle is just length times width, that's all. So here it's just going to be 31 times 21, right? 31 times 20 should be 620, and then plus 31, 651. Let me see, did I get that right? 31 times 21. Yes, 651. And this that pen, I was using a different pen there, a different blue pen. It appears to be running out a little bit, so I'm going to switch to this black one. 651 square inches, right? So the area of that rectangle, 651 square inches. But now the next part down here says, what is the area of the base in square feet? Now, this is why I wanted to get onto this one, right? So again, this is the only example I'm going to do with this. I did several examples of this type yesterday. So yeah, I'll just do this one, and then we'll move on back to the topic that I meant to get to today. But as an example, I'll do out the same thing that I did previously, just to show you what's going on. Imagine this was a box here that was 1 foot this way and 1 foot this way. What would the area of that box be? Or of that rectangle, sorry, it's not a box, square. It's going to be 1 foot squared, right? Because since area is equal to length times width, here area is equal to 1 times 1, so area is equal to 1 foot squared. That's it. That's all you got to do. But now we're converting, right? So all you got to do is find the area, but then how do you convert said area into inches instead? Well, we know that 1 foot is 12 inches. 1 foot is also 12 inches. So the area here is going to be length times width again, but it's the same size of a square, isn't it? It's 1 foot, 12 inches, 1 foot, 12 inches. Same in both cases, right? But here now it's going to be 12 times 12 instead. So that's 144 inches squared, right? And this one is on your formula sheet as well. So it is attached with the unit and will be attached with the test. You just have to remember that you got to go look it up, right? If you don't remember offhand that the conversion factor is squared here, it's multiplied together, it is written out on the sheet and you can go find it. But what we have now is 651 inches squared times 1 foot squared per every 144 inches squared. Inches are going to cancel with inches, and now we are going to be left with 651 over 144, which is going to equal 4.52. So it's actually 4.52 square feet, just like that. Okay? So it is important to remember that whenever you're converting units like that, units of area, your conversion factor is not going to be the same as it would be if you were converting units of length. So I'm going to pop over here now. This is a another sheet that I did up in order to show the surface area of cylinders. Actually, maybe before I do that one. No, well, I will do this first. Yeah. Shouldn't be thinking out loud if I'm just going to contradict myself, hey? But no, it makes more sense to do this part first and then go back to the example off the worksheet 3.4 because it's sort of like these ones, but with a bit more complexity. All right. So find the surface area of these cylinders. I'm going to zoom on in. There we go. So we have to remember, what is the surface area? How do we find the surface area of a cylinder? Like, what is the equation that we're going to use? Well, we know that the surface area is equal to going to be equal to this, 2 pi r squared plus 2 pi r h. Now, what does that mean, right? What indeed? Well, we know that this is the top and the bottom, right? And we know that because pi r squared equals area of a circle. And this one here is the lateral area, or the sides. Okay? I appear to be dropping frames like crazy here right now, so sorry about that there, Twitch chat. I didn't mean to go down and then up again, but Roger's overlords have determined that I will. But anyway, I went over this quite a bit yesterday, sort of to prove why the lateral area is this and why the top and the bottom are this. So if you've got any questions when you're going through, please do watch the video from yesterday that I linked you to, and that will explain these ones. But here now, I'm just going to go ahead and calculate a few of these, right? So question 1 on this sheet gives me a cylinder. I'll just draw out a quick cylinder here. Not super accurate, but it doesn't need to be. So a little cylinder like that. There we go, it's pretty good. Where the radius down here is 6 millimeters and the height is 8 millimeters. So a very, very, very small, like we're talking like 6 millimeter radius, 8 millimeters high. What is this, like a watch battery maybe? Maybe that's exactly what it is. Maybe it's like the size of a watch battery. Yeah, that's about right. So what is the surface area? Well, the surface area, like I wrote out on the other side, is going to be 2 pi r squared plus 2 pi r h, right? Now that surface area is going to equal 2 times pi. The radius is 6 squared plus 2 times pi of 6 times 8, right? 6 times 6 is 36. 2 36s are 72, so 72 pi's. So over here, 6 times 8 is 48. 2 of those are 96, so that's 96 pi's. Down here, we're going to have 168 pi. So 168 times pi. There we go, 527.8. 527.8 millimeters squared. And one of the nice things about this, you see this sheet over here that you're looking at up above me, up there, that sheet, I got that from mathaids.com, which is one thing that I mentioned down here. I mentioned it down, yeah, there we go. Down right about there, my FAQ. Maybe, nope, that way. That way. Right? It's a very, very useful site. One reason it's so useful is because, look at that. Scroll on down and there it is. It's got the answers for you built in. So if you ever want to get extra practice on any units that you're working on, it's a great place to go get those. Right? So that is one question there. Let me do let's do another one. Now this time I'm going to pick one where there's a bit of a wrinkle maybe. Oh, those don't even have units given. Weird. Weird. Beard. Okay, here we go. Weird beard. What was that? What am I thinking? Is it Fu Manchu? Yeah, that's a Fu Manchu song, isn't it? Definitely is. Any stoner rock uh, aficionados in Twitch chat can fire off at me if Weird Beard was indeed a Fu Manchu song, if I'm remembering that correctly. Okay, I'm going to go ahead and draw this cylinder here. Okay, so draw this cylinder here. It's 8 centimeters across the full bottom. So the full bottom like this across here. This is 8 cm. Can you see that, Twitch? Can you see that close enough? That's good, right? That's fine. 8 centimeters down there, and then the height is going to be 12 cm. All right, so we're talking like 8 centimeters by 12 centimeters. So we're talking like a reasonably sized, like, I don't know, glass serving bowl or something that you would store stuff in, like one of those Pyrex bowls, maybe. Okay, so, but again, our surface area is just going to be the same old formula. We got to keep remembering the formula, keep writing it out. It's one of the best ways to remember any formula like this is just to write it down every time you use it. That's what I do. So it's going to be 2 pi r squared plus 2 pi r h. Okay, so the surface area then is going to be 2 times pi times 4 squared, right? Because this 8, you see, is going across. It's the diameter. 2 times pi times 4 squared plus 2 times pi times 4 times 12, like so. Okay? Now, that one is going to be, let's see, 4 squared is 16. 2 times 16 is 32. So that's 32 pi's. Plus this one over here is going to be 4 times 12 is 48. 48 times 2 is going to be 96 again, 96 pi. And then 32 plus 96 is going to be 128. 128 pi. So in terms of pi, we say, that would already be finished. But 128 pi, there like that. 402.12. And that is centimeters squared. Okay? And you do have to remember that those ones are squared. Let me scroll on down. Yeah, 402.12. Look at that. We did it. We are on track for this one. Okay. Yes, there is one more. There is one more sort of twist that I want to get onto here. So actually, if you're still watching, please carry on, because I'm going to mention one of the ones specifically from the activity that you just submitted. So let me grab this one. This one does have a little bit of a twist to it, which is why I want to bring this one up on screen. Okay. Tennis balls are sold in cylinders with a plastic lid. The diameter of the cylinder is 8.4 centimeters and the height is 26 centimeters. Draw a sketch of the cylinder and use it to determine the surface area of the container without the lid. Hmm. 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 What's this without the lid malarkey? Like, what do we got to do? Well, let's find out. So this is still, then, Math 1102A, Unit 3. And this will be worksheet 3.4. What question is this? This is question 9. Okay? So when it asks you to draw a situation like that, what you're being asked to do is, just what I've been doing all along here. Draw out a cylinder. Just a rough one. Doesn't need to be too precise about, say, the curves on the end and on the top and all that. Okay, so let's see. The diameter of the cylinder is 8.4 centimeters. So like the last ones, I'll do a dotted line to show the line that's sort of in behind. And the diameter is going to be, well, we know the diameter is the distance across distance across a circle going through the middle. Right? So that's the diameter. So we're going to have the diameter is 8.4 cm, like so. Right? And then we have the height. So the height is 26 centimeters. Okay? And then it's asking us to find um, the surface area without the lid. Right? So how are we going to do that? Well, we know that we have to start off with our surface area formula because we always have to, right? Which is 2 pi r squared plus 2 pi r h. And as an aside over here, like I mentioned before, part of understanding how we do a question like this is understanding what the different parts of this formula represent, right? Because we know that the area of a circle is equal to pi r squared. Pi times the radius squared is the area of a circle. Oh, scrolled up a bit too far. There we go. So I'll say, therefore, we know that 2 pi r squared is the area of two equal circles, the top and bottom. Okay, of course, right? Now that's the top and the bottom of the cylinder. So here now, we were told that we need to find the area without the lid. So if we're going to do it without the lid, how is that going to look? Well, the 2 here is what makes it have a top and a bottom. So we are going to do away with the 2 because of what we've got written over here in green. We know that we don't need a 2 in front. We actually just need a 1 because it's going to be surface area is equal to pi r squared plus 2 pi rh, right? And this is the bottom, and this is the sides. Okay? It is important to know which part of the equation represents what part of the cylinder. So here now, I can go ahead and just fill these in and solve. So the surface area is going to equal pi times the radius squared. Now remember, here we're given the diameter, not the radius. So in order to find the radius, you're going to have to take half of that. It's going to be 4.2 squared plus 2 pi 4.2 times 26. Right? And that's all there is to it. Really. Just going to go ahead and keep solving here. Turn this back on. 4.2 squared, 17.64. So that's 17.64 pi plus 4.2 times 26 times 2. 218.4 pi. Now you don't need to leave these in terms of pi like I'm doing, but I'm going to. So that equals 236.04 multiplied by pi. So I'm going to times that by this one. Leaving it as a value of pi as late as possible simply allows me to round as little as possible, basically. That's going to be 741.54. And what is this? Centimeters squared. Right? There we go. So that is how you would do that one. And it's really important to know this influences what's being shown on here. Right? And that's why we had to cut off this one here. We don't cut out one of the radiuses, or the radii here, because that would change, that would substantially change what the question is, right? Because really what we have, yeah, this is a good way of explaining it. Really what we have is SA is equal to pi r squared plus pi r squared plus 2 pi r h, where this is the top and this is the bottom and this is the sides. That's really what we have. But we normally don't write it like that, right? This simplifies to SA is equal to 2 pi r squared plus 2 pi r h. Right? So that's just, it's another aside over here. It actually simplifies a bit more than that too, but you know, we're not going to go over that because you don't really need to know it. Okay? All right. Seems good to me. Okay. So, Ashley, I hope that was all that you needed for those topics. Now, again, right, this is the last email, the last stream before Easter break. If you do have any questions that you want me to get to before the end of today's stream, yeah, please email me soon. We're gonna be ending there now in a bit, but I do have this last little part to go over as well. So this is chapter 13 pre-test we see over there. So this is for Prism Math Blue. So I'm going to go down through this page. Then yeah, today might be a quick one. This is Prism Math Blue page. What the heck page is this? 196. Now this is a pre-test, right? So you're never responsible for these pages, which are why they're really good to do, for me to do as examples. They're also good for me to do as examples because they contain sort of all the different bits that you're going to have to know in that, you know, in that unit, right? So it's a good one to review with as well. So these first few questions are all about this pie chart that's here. So let me zoom on in. Takes a while to get much zoomy. There we go. So let's zoom on over, scroll on over. Yeah, it's tough to see it close enough. How many adults take the subway to work? Blank adults. Well, let's zoom in then. So this is a pie chart showing how adults get to work. Yeah, transportation of 2,000 adults. Right, gonna zoom out a touch. Okay, that's not bad. There we go. Good stuff. Okay, so asking us how many adults take the subway to work. Okay, well, how are we going to figure that out? Well, subway is 11% of 2,000 adults. Right, so how do we find what number that represents? Well, remember, subway, so it's some number, is 11% of 2,000. Right? So let me fill that in. Some number is 11% of 2,000, right? So that's how we would go through and figure those ones out. So now I can just go through and multiply. So I'm going to do 2,000 times 11 divided by 100, 220. So x equals 220. We know 220 adults chose to go to work via the subway. So what's number 2 going to be then? Let's see. How many adults drive a car to work? I think you're seeing how this goes, right? So car is 47% of 2,000 adults. So again, like the previous one, I will say x is 47% of 2,000, right? And just knowing how the math writes out into words can really help you be able to approach these questions, even if you're not super familiar with how it's done off the top of your head, right? So x is going to be, and I'm just going to go ahead and multiply. I'm going to do my 47 times 2,000. Of course, I could divide 2,000 by 100 first, just to make the math a touch easier and be able to do it in my head, but that's fine. 940 people. There we go. Yeah, the other ones are pretty similar to those questions, so maybe I'll just breeze past those. So they ask us to find the mean, median, and mode of each set of data. Okay, this is a good question. It's a good question because it goes over a lot of the stuff that you need to go over. So I'm going to do question 6 here. So the numbers we've got are not in order there. Okay, so one of the things that we're going to need to do is first put the numbers in order, right? Always have to do that. Got to put them in order first. It's going to be 49, then let's see, 52, 53, 55, let's see, 62, 67. Oh, there's two 49s. 55, 62, 67, and 73. Now, are those all the numbers? Let's see. This is 1, 2, 3, 4, 5, 6, 7, 8 numbers. Over here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Well, crap, I missed one. What did I miss? 53 is there, 67 is there, 49, 149 is there, 52 is there, and the 49 is there, 73 is there. Oh, 80. 80. There we go. Easy enough. Okay, so I'm going to do, let's do the mode first for these ones. The mode is simply going to be the most common number. So there's two 49s, so the mode equals 49. It happens to be the lowest number in this set, but it's still the mode. Right? The median is the next one. The median is always the middle number. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers here. So the median is going to be the fifth one. It's going to be n plus 1 over 2, which is 9 plus 1 over 2, which is the fifth number in order, which is going to be 55. 55. Easy. And then, so the last one is going to be the mean. And the mean is the meanest one because you got to do the most work for it. But the mean is the sum of all the numbers divided by the number of numbers, which is going to be 49 plus 49 plus, oh, this pen's running out. All right, I'll go back to the black one. 49 plus 49 plus 52 plus 53 plus 55, blah, blah, blah. I should have this be like a one of those old school cooking shows. Have you seen these? Well, they'll be like, we gotta make this casserole, right? And the casserole's gotta sit, or make this dough. Yeah, we gotta make this dough to bake these pastries or whatever. The dough's gotta sit and chill for like 4 hours first before you can put it in the oven. But here, I got one that I already made and already chilled. Boop, and then you go straight in the oven, right? I mean, it's nice for TV and all, but it sort of kind of dispels the illusion that you can actually cook the thing as quickly as they're showing it. Oh, I was showing you the my tabs. My tabs. So let's do 49 plus 49, 52, 53, 55, 62, 67, 73, 80. 540 divided by 9, 60. So the mean is 60. All right? So here now, right, we can see all the three of the measures. Mode, does mode look like a very good measure of central tendency here? No, it really doesn't, does it? The mode is a bit helpless. Like the mode just happens to be 49, the lowest value, but it happened to come up exactly. The lowest value came up twice, but it is still the lowest one. Not a great measure for the middle, now is it? The median and the mean are both very good measures most of the time, but it's worth remembering, right? That the median is less susceptible to outliers, but is very susceptible to clumping. Whereas the mean is, say, um more resistant to clumping, but is vulnerable to outliers. Okay. Yeah, I guess I don't really need to carry on and do the next part, do I? Right? Because the next part is just the same sort of deal. Same sort of deal again with mean, median, mode. Okay? So I think Renetta, if you're watching, I believe you're already good on those ones anyway. So let's just do a quick review of these probability ones that are over here, right? And I'll do these over here on the side of my page so I can keep having it in the same spot. So this will be question 7. Now let's move on to. All right, that was 6. That wasn't 6, that was 6A. 6A. Okay. So, Mr. Alvers, what are we asking? Choose a teacher. You will draw one of the cards below. Write the probability in simplest form that you will pick Mr. Alvers. Okay. So, how can we figure out if we're going to pick Mr. Ken Alvers? Boy, they haven't got very many first names in this place. Look at this. There's 5 teachers. Here's a probability question for you. Here's a probability question for you. If you randomly pick 5 teachers, what are the chances that uh, 3 of them are going to be named Ken, right? Ken Alvers, Ken Bruns, and Ken Von. And also Mr. Bruns, Bruns. That's got to be Mr. Burns, right? That's supposed to be Mr. Snrub. I like the way Snrub thinks. Yep. Seeing I'm entertaining myself on stream, hopefully drowning out noise. I'll yeah, just make Simpsons references. Just recite episodes of The Simpsons. That's the best. That's the best content. Let's see. Mr. Alvers is going to be, well, there's just one Mr. Alvers, right? There's one Mr. Alvers out of 6 favorable, right? Because remember, probability is just, right? Remember, I'll write this in a bubble. It's just favorable divided by total. That's all. Right? Favorable is 1. There's one Mr. Ken Alvers divided by 6 because there's 6 teachers. Right? If there were multiple Mr. Alvers, then, you know, it would be a different number. But there ain't, so it's not. We scroll on over here. A man. Boy, I really got to zoom out on these ones. This page is a bit tough to see. Tell you what, Twitch chat. Let me that's a little bit better. That's a bit better. There we go. Now I can see it. Okay. So we're over to my other scene here. This is a bit better, yeah. Yeah, so Mr. Alvers was 1 out of 6. A man. Well, we've got Mr. Ken Alvers, Mr. Ken Bruns, and Mr. Is that also Ken? It is Ken. Mr. Ken Von. I already talked about that. And Mr. Pat Wither. Right? So there's a Ms. and a Mrs. And then 4 Misters. So I'll assume those Misters are the men's. That'll be 4 over 6, which equals 2 over 3. Easy enough, right? Number 9, Mr. or Mrs. Vaughn. So I guess that's Mrs. Pat Vaughn and Mr. Ken Vaughn. 2 out of 6, which equals 1 out of 3. I think you're probably seeing how these are going to go down. Person who has a first name of Pat was Mrs. Pat Vaughn, Mr. Pat Wither. I guess that's okay. I guess we take both of those because did just say Pat, right? But I mean, Pat is probably short. Probably Patrick and Patricia. Mrs. Patrick Vaughn and Mr. Patricia Whittler. Whittier. Anyway, what am I rambling about? Person who has the first name of Pat, 2 out of 6 equals 1 out of 3. And then number 11, person who does not have a first name of Ken. Well, obviously everybody has a first name Ken. It's just teachers. Teachers all have the first name Ken. Right? So, let's see. That is going to be 3. 3 out of 6 equals 1 out of 2. All right? And there we go. That is some prism math blue for you. Switch on back over here. There we go. All right then, folks. I know this is a rather short stream today, I guess, but yeah, managed to get to all the topics that people wanted me to go over. Yeah, I hope you're holding up well for the distance teaching, right? Of course, you know, we're doing all we can to try to help people out, and I hope that if you guys have any issues or any questions or anything like that, you won't hesitate to let us know. Right? You try to zoom in and get a little buddy. There we go. Get a little buddy in the picture. There you go. Little tiny buddy. Okay. Yep. So this will be the last math help stream now until April the 20th. Right? That's the Monday after Easter holidays. That's when we're back in the classroom, such as it is. Yeah. Please keep following, say, the NL Health advisories, which do come out at usually 2 p.m. every day. I'm actually going to be ending before it even comes on today, so maybe I'll bounce over and watch that one. I don't know. Yeah, the one yesterday at 6 p.m. was very informative, and would recommend everybody check it out. Yeah, just stay safe. Hope you're carrying on with your math over the break or any of the other academic questions that you might have. You can send them to me on email. I cannot guarantee that I'm going to get to see them, over the break. But you're welcome to send them to me. I will, if I don't get back to them during the break, I will definitely get back to them on the Monday back. But of course, you won't be expected to complete any courses over Easter, even though it might not feel a whole lot different than these past few weeks of classes. Excuse me. So, yeah, I'll leave you there. Um, Stay safe, everybody. Have a great and happy Easter, and yeah, I'll see you again in I guess like a week and a half.